Good day, my name is Gordon O'Brien. I am a scientist from the University of Mpumalanga in South Africa. Today I'm going to be presenting a blended learning module to you. This is the second in a series of 5 blended learning modules titled the Nile eFlows Framework and its Application. This is produced by Hydroc on behalf of the Nile Basin Initiative through a study titled Course Environmental Flow Assessments for Selected Sites in the Nile Basin. I would encourage you to please look at the introductory module, which has a detailed explanation of the context of these blended learning modules as a part of the strategic management for environmental flows in the Nile Basin. And that includes the establishment of the Nile eFlows framework in 2016 and how eFlows are proposed to be implemented within the Nile Basin in the context of Sustainable Development Goals. There are 5 blended learning modules as I have suggested. The first is the introductory module, which I would encourage you to go and look at for a more detailed introduction. This is the second of the modules titled the Nile eFlows Framework and its Applications. The third will be looking at assessment methods, advantages and disadvantages of those different methods. The fourth, we will look at environmental flow assessment applications in Africa, and there I'm going to highlight one of the applications of the use of proper holistic environmental flow assessment method, just to give an idea of how they are undertaken. And then finally we're going to look at the implementation of environmental flows framework, and there in particular we're going to look at Sustainable Development Goals, for example. The structure of these blended learning modules is presented here, where I'm just going to show you for these 5 modules that are available in the series. This is the second. The content of each of the modules is the same. It includes an introductory section, and objectives of the modules section, contents of the module, lessons, and then further reading recommendations. And I provided a key on the right hand side of each slide just to allow you to get an idea of where you are in each of the modules. To start off with, again, just to highlight that the NBI recognizes that the sustainable management of shared Nile Basin water resources requires the establishment of relevant transboundary policy instruments, and that is a part of the Nile Basin Sustainability Framework. These policy instruments needed to conform to existing environmental and social policies. The sustainable use of these socio-ecologically important water resources of the basin require the coordinated management of environmental flows on meaningful spatial scales. And that need specifically to address environmental flows on different spatial scales is where a framework for environmental flow assessments is needed. In 2016, the NBI did not have any general standards and norms for the establishment of environmental flows in the basin. The NBI initiated then a process to develop a transboundary level guidance document for environmental flows. The objectives and guidance of the guidance document on environmental flows was to develop a structured and scientifically based eFlows framework for establishing eFlow requirements and managing flows in the basin for transboundary water resource planning and purposes. That all resulted in the Nile eFlows framework that was established in 2016. The objectives of this module is to present the Nile eFlows framework and its implementation in the context of the course environmental flow assessments for selected sites in the basin. These are the 5 components of contents of this module, and they include introduction to eFlows on regional scales and considering frameworks, then the Nile eFlows framework itself, procedural steps of the Nile eFlows framework, roles and responsibilities of stakeholders of environmental flows and their assessments in the Nile Basin in the context of the Nile eFlows framework, and then course eFlow assessments and the Nile eFlows framework itself. To start off with, we'd look at the development of environmental flow assessments and assessment methods, policies, procedures globally. And this information is provided from a review of environmental flow assessments that initiated in 1990. And the first important thing is to consider the first green curve, which is a representation of how much information has been available on the environmental flow assessment subject based on the number of publications. And you can see from this line, from the 1990s, we really have had an emergence of environmental flow assessment information through publications from the 1990s. And although later we're going to touch on it, but these are the different 4 phases of environmental flow assessment development that the world has undergone, and these are categorized as an emergence and synthesis phase, consolidation and expansion phase, globalization and new challenges consideration phase at that point in the 2010, from 2010 to about 2015, and then where we are moving into a future environmental flow implementation and management phase. The blue curve represents the portion of developed resources, and if you just compare the green curve and the blue curve, you can see that the amount of water resources that have been developed that require environmental flow determination is also increasing. So as the world develops, and now importantly we need to consider developing regions such as the Nile, the information pertaining to environmental flow assessments has also gone up. So we have an opportunity to develop in a sustainable manner. These represent the different phases which I've discussed already, and then these red components represent the different all those milestones of the development of environmental flow assessments, including methods, modules, Brisbane Declaration on what environmental flow is, and very importantly here you can see where the frameworks for environmental flow assessments, ILOA and SUMA, have been established. And where are we today? We have a framework that was developed in 2016, and the Brisbane Declaration 2.0 has been established, PropFlow has been developed, and other methods. And at this point we're looking at the implementation of the Nile eFlows assessment framework. Okay. Now we move on to frameworks. What are frameworks? What is an environmental flow assessment framework? In the next module, we're going to talk about environmental flow assessment methods. But if you step back from just looking at a method to determine environmental flows, I'd like to consider what is a framework. So on a regional context, where we're not only considering one reach of a river that's being affected by any type of development, if we look at a basin, and this could be, in this case study, in this context, we consider the Nile Basin. We have got one major river system, the Nile itself, but a plethora of tributaries, and they are very important, not only to contribute to the amount of water available in the Nile itself, but the Nile and connections between these resources, those resources themselves, and the ecosystem, the biodiversity and ecosystem services that depend on those resources, as well as the livelihoods of all the people in the Nile Basin, are all connected through this massive basin, this important catchment, and its tributaries, and all the associated water resources that are all connected, and they then need to be managed in a coordinated manner on a basin scale. That's one of the purposes behind the Nile Basin Initiative, and what's very important is that through the development of these environmental flow assessment frameworks such as ILOA, that was considered to be an important initial consideration, that we need to be able to manage environmental flows and water resources on a basin scale, on a large, meaningful scale. And from an initiative perspective and guiding environmental flow assessments, if any environmental flow assessments are being undertaken on a regional site scale, regional scale, sub-basin scale across the basin, all of that information should feed in to a larger framework, where that framework can then address environmental flows on a basin scale, on a larger regional, meaningful scale. And that is something that we're working towards. So ILOA was developed, and these are the different steps in the ILOA framework. So I presented the framework to you here. And what's important about ILOA was it was the first meaningful, formalized attempt to be able to carry out multiple environmental flow assessments and apply the information that is learned from detailed assessments across a different catchment area to resources or ecosystems that have got similar characteristics. And as a result of the similar characteristics and the similar understanding of and our understanding of flow ecosystem relationships or flow ecosystem service relationships, it would give us a low confident ability to then understand what the requirements may be of those areas that we haven't looked at, and what as a result the environmental flow requirements of those small ecosystems or those ecosystems would be that have not been a part of the major assessment. And that is why it was established. So it includes these major procedural steps. The first is a hydrologic foundation step, where we need to understand flows and flow statistics, and we need to understand present developed hydrographs. What is the current water use scenarios in the context of what the hydrographs and the precipitation and the availability of flows would look like historically, that is pre-development. We do know that we go through different wet phases and dry phases, and what's important to understand there is that there is a probability, a high possibility, that we will continue to have wet phases and dry phases. So having an understanding of our hydrological foundation of flows and flow variability is very important, and based on what those foundational flow or reference flow hydrographs would look like, we need to understand what the present developed hydrographs look like and what some future scenarios of development may look like, so that we can develop resources in a sustainable manner by ensuring that there is a balance between the protection of resources and the allocation of flows to maintain those ecosystems and to allow development for the benefit of vulnerable African human communities. That's really what we're aiming at here. So the first step is to understand how has the flows, what has the variability of flow been like within the basin, how has it changed, how will it change in the future. The second step is to understand what it is that we're dealing with, and this is where we consider the hydrologic classification of different ecosystems, geomorphological considerations and sub-classifications, and that would lead us to understand what the different river types would be. And remember, this is focusing on lower, which has historically been established, and we're going to, this is not the Nile eFlows framework yet. But what was important in step 2 of the lower framework was to identify what was the actual ecosystem that you were dealing with, and where there are similar ecosystems that are dealing with similar types of developments, with similar type of potential flow alterations, would there be a similar response in that type of ecosystem compared to this ecosystem? And ensuring that you know what the river type is foundational to that understanding. The third step would be to look at flow alterations for each analysis node. Here we would look at the assessment of the different flow statistics and understand, is it the volume, the timing, the duration, the frequency of flows that's going to change, and whether or not an understanding of how the flows will change will influence that river ecosystem or that aquatic ecosystem that we're dealing with. And when those two components come together is where we need to understand from a lower perspective that was emphasized the importance of ecosystems only, was to establish these flow ecosystem hypotheses, these relationships for these different types of ecosystems, to collect the type of data that would be required to understand and to develop these response relationships, these relationships between flows, how the flows are going to be altered, and the different ecosystems and the attributes of those ecosystems and processes associated with those ecosystems and altered flows. And what's very important then, as soon as we understand those relationships, we can use that information in different parts of the basin, for example, to then understand what the consequences of altered flows would be on a meaningful spatial scale. We're starting to be able to apply and use this information on a regional context. And what's important for us is this balance between evidence and making sure that we have evidence to understand how the flow ecosystem relationships, but then importantly, once we have that information, to understand how we can use that information and to monitor the consequences of any decisions we make to improve our understanding of flow ecosystem relationships. Once we have that information and we know what river type we're dealing with and we know what it is that we want to achieve in the context of a sustainable balance between the use and protection of environmental flows, we need to establish these standards. And those standards are very, very importantly based on the society, and how society in the context of the basin then decides what an acceptable balance would be between using and protecting that environment in the context of sustainability, always in the context of sustainability. And that is where these targets, these standards have to be established in the context of regional and targets or objectives that can then be informed by sustainable development goals. And we would then be able to implement. And very importantly, on the left-hand side over there would be the monitoring, because as the cycle rotates across the basin, as we start to implement such a framework, we'd be able to learn from our adaptive management, and we would be able to improve our understandings and improve our ability to manage environmental flows into the future. And the first framework that presented that to us is Iloa, and all frameworks that have been established thereafter have really had their foundations in Iloa, which is what you're going to see for the Nile eFlows framework. Okay, so I've highlighted these outputs of the framework because those are the different attributes of the framework that are carried through. It's to understand what is the ecosystem that you're dealing with, what is our understanding of how flows in that system will be altered, our relationships and our understanding of relationships between ecosystems and flows, and how flows will drive those ecosystems, and the formation of environmental standards so we can manage environmental flow. Here's a quick example, and this is a mock-up just to give you an idea of how it could be implemented in South Africa in the context of resource-directed measures. So in South Africa, we have procedures that have been implemented for one of our water management areas in South Africa called the Olifants River. Olifants is an Afrikaans word for elephants river, and the Olifants River in South Africa is one of our most important socio-ecological systems that supports a huge portion of our economy as well. So what we understood and what we knew within the catchment was it's quite a large catchment. You can see from the scale there that it is over 100 kilometers long. In relation to the Nile Basin, it's not that large, but the principles should be sound. And in terms of this, the significant, what the South African government refers to as significant water resources, we identified rivers, wetlands, groundwater, and lakes or dams as important water resources. And that's where we know that we would need, from an Iloa context, to try and establish our relationships between flows and measures of flow alteration and how these different aquatic ecosystems would respond to these changes in flows. We did have some data, and that's represented here in the map in the green nodes, where we do have some information from these green nodes, but all of the yellow nodes were selected to represent these sub-catchment areas, and a large part of this catchment area we didn't have data for. So the formation of a framework and the implementation of a framework for Iloa was important for us, because we would need to understand what the potential consequences of altered flows would be in some parts of the catchment that had very important social or ecological features, and we did not have the data available to go into that area to collect the data to establish environmental requirements for that area in particular. So what we did have for the nodes that where some data was available was relationships between ecosystems and flows and non-flow variables. Consider water quality, for example, temperature and dilution requirements for some toxicants, for example, and habitat preferences and velocity preferences of different indicator species. So we had some understanding of this flow alteration ecological response relationship for these different parts of the catchment, and the variability of the relationships between the ecosystem and flows, and that would represent the resilience of different types of water resource types. So along the whole basin, from the source zone up in the higher altitude areas of the plateau in South Africa down towards the Kruger National Park, we would have a continuum of different types of water resources. In this case, we focused on the river ecosystems and our understanding of how the flows affect and the different attributes of that ecosystem along the length of the river. And that information was available to us. What we then did was we reviewed the recommended ecological categories, so we had some understanding of what the environmental flow standards would be and how to determine those standards based on the categories. We also established resource quality objectives for the study area. We had an understanding of what the present ecological state would be, and this is using the classification system, and you can see here that D is the limit of sustainability, these dark green. So this is a highly utilized resource. Most of the water resources are in this D ecological category, which suggests that they're on the border of sustainability. There are many parts of the catchment that are presently in a EF and ecologically unsustainable condition. So there's, in the context of objectives, there's a lot of work that needs to be done in this basin. We are not necessarily achieving the resource quality objectives yet, but now that we know what the objectives are, we know what to work towards. And then we had information on other types of ecosystems and our understanding of what's driving those ecosystems. We have relationships. So we implemented that information in an environmental flow assessment context, and we would be able to generate this type of map where you would be able to look at the resilience of different types of river ecosystems throughout the basin, and based on that information you'd be able to determine an indication of what would the minimum environmental flow requirements be for different ecosystems across the basin. And although we only have certain parts of the basin where we have real data, by applying a framework and using the evidence that we have, we would be able to start to manage the environmental flows across this whole basin, and you'd be able to provide information by applying that framework throughout the whole basin. And that information then would be of a low confidence, but as we then apply an adaptive management process, and applying the framework requires the monitoring and learning from our projections, we'd be able to improve our understanding of the resilience of the system, the response of different ecosystem types to altered flows, and we'd then be able to improve our management of environmental flows across this basin. So this is an example, but this is what a framework is trying to achieve. It's allowing us to manage environmental flows on these large, meaningful spatial scales. So this is the result of many environmental flow assessments that have been undertaken over many years in the basin, and how we utilize that information with this framework. So what are we trying to do with the Nile? So flow variability and multiple anthropogenic stresses of flows, and that are driving flows, need to be managed in a collaborative, coordinated manner in the basin where everybody is connected. And this is the idea, that everybody is connected in the Nile Basin, and some of the development is starting to affect many different attributes of this basin. And although it looks complicated, it can be decomplicated, but we need to understand how to manage and utilize and develop the basin in an equitable manner where everybody shares, but we can ensure that that development results in a sustainable ecosystem. And this is an example of, if all of the water in the basin could be poured into a beaker or a glass, this would be an indication of what the present allocation of flows is in relation to environmental flows. And we get an idea of where we have the allocation does not exceed the environmental flow requirements, and all the environmental flow requirements in the context of allocation, and how much water is available, and whether or not we are starting to tap into those environmental flows, or we're starting to threaten the environmental flows by the amount of water that has been abstracted from those the flows available across the basin. And this information across the basin would allow us, because of the connections of the basin, it would ultimately, eventually, in the future, allow us to, and all the stakeholders of the basin, to start to utilize and manage water resources in the basin in an equitable manner. And that's what we're trying to achieve with this framework. So this required the development of an application for a regional environmental flow framework for the basin, which would allow us to learn from all of the environmental flow assessments that are being undertaken, and to build that database, so to speak, of environmental flow ecosystem response information with altered flows, and then to start to apply environmental flows across different parts of the basin, which we would never be able to achieve if we had to do every system one by one by one. The question is, this is what Nile eFlow framework has been designed for, to achieve in the basin. Okay, so these are the management practice principles that have been foundational to the formation of the environmental flow framework, and the framework would need to embrace the principles of collaboration, that we need to work together, that we need to share benefits, we also need to share the information. We need to ensure that we embrace sustainability, that we do not want to affect the ability of these resources to provide services to future generations. And we also consider the sustainability of the globe in Sustainable Development Goals. These assessments and this framework must be evidence-based, that we use the information, the data that we have, to make important decisions, and that we need to monitor the information, or monitor the implementation of some of these decisions, and monitor these changes, so that we can increase our understanding of how these environments or these ecosystems respond to altered flows in the future. we need to embrace this aspect of requisite simplicity. What is it that we need to know, and what is it, how can we, as easy as possible, with as little as is necessary, achieve the goals that we have? And that is where we're trying to balance limited resources with the need for evidence or information to achieve the ultimate goal. So we really are embracing this concept of as little as is necessary to manage these resources effectively. And that means that we have to work smart, we have to think before we just act. We need to embrace the principle of transparency, and that everything that is collected and everything is known is available to allow for the greater basin scale management of water resources. We also need to embrace the aspect of adaptability, that we can't wait for environmental flow assessment frameworks or methods to be established and implemented before we start developing resources. So we need to have an adaptability approach and a precautionary approach to water resource development and learn from the implementation as we start to develop these resources. But we do need a precautionary approach, and as soon as we are available to establish these environmental flow requirements that ensure that the development can be undertaken in a sustainable manner, that is the ultimate objective of these frameworks. This resulted in the formation of the 7 procedural step environmental flow framework. And I just quickly want to read these different steps. It's quite small, but it should be okay. The first is to look at basin scale situation assessments and alignment. It's to start for the first time to start to put together what's going on in these sub-basin areas, what's going on in these across the basin in the context of connectivity, what has been done, what have we learned from what has been done, and what are we trying to achieve. The second is to look at the governance and how we, all the different stakeholders can come together to start to establish and implement environmental flows. If there are stumbling blocks from a socio-political or ecosystem perspective that are going to affect our ability to implement outcomes of this basin, we need to start addressing that in the beginning. And one of the foundational considerations we have within this governance step is to consider resource quality objective settings, which really is those environmental flow standards, or the environmental standards or the targets that can be related to sustainable development. And I think that's something that we all agree on, is that we want to achieve that sustainable balance between the use and protection of resources. And in the second step of the framework, that must be considered, so we know where we're going, we know where we are, and we know we know the direction we're taking. Then, which has directly been exported from the ELOA framework, is a Hydrologic Foundation component, an ecosystem type classification component that moves on from rivers towards ecosystems, because we know that we have wetlands and their floodplains, rivers, floodplains and wetlands, lakes and estuarine ecosystems that are all connected within the basin. We're also very interested and need to, which has been exported from ELOA, to determine flow alterations. We then want to establish flow ecosystem and flow ecosystem service relationships. So from SUMA, another framework where social attributes of water resources and the environmental, the ecological or ecosystem services that are derived from ecosystems and how they benefit communities, that's considered. So in that step, we want to consider flow ecosystem relationships and flow ecosystem service relationships together. And that will allow us to set these environmental flows and to monitor the flows. And then in an adaptive context, we'll be able to implement the framework and continue to learn and improve on our understanding of the resilience of the system, of the effect of altered flows, of the vulnerability of our different ecosystem attributes and human communities, for example. And importantly, we will improve our ability to manage this resource in a sustainable manner. Okay, as a part of the development of that process, we developed these 3, just 2 of them are shown, but there are 3 background documents which we've mentioned, a technical implementation manual, and then the strategy that all resulted in the establishment of the strategy for environmental flows in the Nile Basin, which refers back to the manual and the framework. Here we are. So that's the 7 procedural steps of the framework. And what we're going to do now is we're going to unpack these 7 procedural steps to present the different parts of the Nile eFlows framework to you. This is a flow diagram of the different procedural steps and the subcomponents. And what I'd like to introduce here is the differences between planning, alignment, and governance phase, which is highlighted in red, which is steps 1 and phase 1 and phase 2. And then you have a scientific environmental flow evaluation section where scientists, so stakeholders are important in establishing and contributing to these first 2 phases, and then human resources, experts, scientists, managers are then required to then implement the second part, which is a scientific environmental flow assessment section. Getting back to the content of the framework, just we're going to go through each phase step by step and show you how it was developed and what are the components of each of these phases of the Nile eFlows framework. The first phase is the situation assessment and alignment phase, and this is where we understand that the different sub-basins of the whole basin have different countries. We know that the different activities, the opportunity for activities, the opportunities for development have been very different. We also understand that the characteristics of the resources are different, and that the opportunity for those resources to be used in different parts of the basin differ as well. We also understand that different countries have got different management policies, and they would consider the balance between the use and protection of resources differently in different parts of the basin. And one example would be the high protection emphasis of the upper Mara River in Kenya because of the Masai Mara Reserve and important ecological processes that are world-renowned, compared to some of the lower regions of the basin where there's a lot more emphasis on the use of the resource, still ensuring that the resource be used in a sustainable manner, but the importance of utilizing the resource and alternative sources of opportunities for water resources would be very different. In Kenya, for example, they have got west and east flowing water resources, and they would be available to utilize the resources differently. But if you move down the catchment towards Sudan, South Sudan, and Egypt, they would have very limited alternative resources other than the Nile to sustain their ecosystem. We also consider differences between opportunities in resource use and protection opportunities around lake ecosystems, river ecosystems, for example, and that's important. So what we proposed, first of all, in the context of environmental flow assessments was a scorecard, and the scorecard has many different attributes or components. So what we proposed was that in order to start collecting the information from different basins and starting to apply the framework for different sub-basin levels that would then feed into a basin level application, that we need a certain amount of information, and we would guide future environmental flow assessments to collect this type of information to help us implement the framework. So this is a very simple scorecard, and some of it has been applied. There are some more detailed versions of the scorecard, but what we proposed, what was important information from an environmental flow assessment perspective that would allow us to contribute towards the framework would be, and it's these 12 points over here, is to consider, do environmental flow assessments, have any environmental flow assessments been undertaken, and what type of methods were used, and to comment on that and to provide a score for how suitable the methods were. And we'll talk about the methods in the next module. Were ecological water requirements, in-stream flow requirements, or ecological flow requirements determined? Yes or no? And what's that information? What is the uncertainty associated with the approach or data available or presented in the determination of those in-stream flow requirements, environmental flows, for example? Because that information would then be used in other assessments. So knowledge of the uncertainty associated with the establishment of these environmental flows is very important. Was stakeholder engagement process included in the assessment? And explain that. Were there any transboundary considerations? And this is more regional scale considerations as well. What is the local socio-ecological management objectives and were they established and assessed in the assessment? What are the resource quality objectives established and assessed? Were they assessed? What are the targets for that balance between the sustainable use and protection of resources? On a regional Nile sub-basin level, were socio-ecological management objectives established and assessed? Were regional resource quality objectives established and assessed? Has the Nile Basin eFlow management objectives been considered? That's on a basin scale. Because that's what we're really trying to encourage with this framework, is that people start to consider that they're part of a larger system and they need to manage their water resources in the context of the management of the entire basin. Okay. That's something that is being worked towards. What is the level of confidence of the assessment? Was the environmental flow assessment method implemented in a suitable manner? What is the suitability of that method as well? What is the potential for the use of the data, the findings and recommendations in the Nile Sub-Basin Environmental Flow Assessment? So in terms of the application of the framework, is the data that was derived from these case studies available and can it be used in the framework to look at regional scale assessments? What is the potential for the use of the data, the findings and recommendations in the eFlows assessment? So what we would do is we would apply a simple scoring system to then recommend whether these existing environmental flow assessments or future assessments are going to provide the type of information that would feed upscale into environmental flow assessments on a larger regional scale, which is what the framework is trying to achieve. Secondly, we would look at the next phase is the governance, management and RQO setting phase. And this is where we would look at the relationships between societal needs and values and legislation policy considerations. And that would be based on these trade-off assessments and negotiations between the desired ecosystem well-being and the desired use of that resource. So if we can get the balance right between the desired protection or the protection requirements of the resource and the use requirements and have some trade-offs, we would then understand within a legislative context and the livelihoods and the needs of the livelihoods, we would then be able to establish this vision for the resource. So the vision of the resource is based on the trade-off analysis and negotiation, and that's in the context of societal needs and values, legislation, policy from the region, the protection objectives, the use requirements. With that information, a vision is established for that particular resource. And that vision is then translated into the quantity, quality, habitat, and biota characteristics that represent targets or objectives for those resources. We're going to talk about that in a moment as well. And once that is established, we can then move into the next phase. I think that we've unpacked that slightly here. Yes, we have. Okay, so that's the first step and the sub-nodes. And what's important here is that the vision describes society's aspirations for the resource, interactions with the resource provided by the Nile River. And that's where the vision comes from. The RQOs that would then be established that would describe the resources of the Nile as they should be. Example would be good water quality to provide safe water for domestic use. Another one would be the quality of water to keep the ecosystem in a good condition and provide food for fish, or provides, and there would be many, many, many other objectives that represent that balance between the use and protection of the resource that would then achieve this overall vision. The targets that are established, described in RQOs in relation to the components of the ecosystem that need to be managed, i.e. quantity, quality, habitat, and biota, as I've suggested. So here, if you're looking for good water quality to provide safe water, the targets would be to ensure that the water quality is suitable in the terms of the pathogens, and you'd also have good water in quality and water quality in the context of salinity. So you would have these different targets that you could go and measure to ensure that you would be able to provide these RQOs that would then meet the vision. And in the context of looking at maintaining an ecosystem and good quality to provide food for fish, you'd be interested in sustainable source of food for fish is provided, for example, and environmental flows are established to keep the ecosystem in a good condition according to the different months of the year. And if that information is available, then you would be able to achieve your RQOs that would then all feed up into achieving the vision. The indicators for different types of these targets, which is what would be incorporated into a management plan, which is what in an adaptive management context we would test to see whether this is indicative of the targets, which would then allow us to achieve the objectives, would be things like to ensure that the E. coli concentrations or counts are maintained below a certain amount per 100 millimeters of water, that the total dissolved salt concentrations in milligrams per liter would be below a particular level, that the stocks of fish in tons per annum would be maintained in a particular type of river ecosystem, for example, and that the environmental flows and what that actual value and the associated variability of flows would be for a particular type of month. And this is the procedural step, which has been published and presented not only in the manual, but other sources would show how these indicators, targets, RQOs, and visions can all be integrated to achieve that overall balance between the use and protection of resources, water resources, in an environmental flow context, and that can be achieved for the Nile Basin. The next phase is to move on to is the Hydrologic Foundation, and in the Hydrologic Foundation component, this is from also been imported from the lower framework, and here what we would consider is the available river flow water. We'd look at mean annual runoff, we'd look at variation in seasonality. Here it's important here to consider what the historical variability of flows would be. So we'd look at these reference hydrographs and the developed hydrographs in the context of what has changed already. We have information already on what the basin has looked like and how things have changed. We would then be able to look at basin characteristics and climate data and that's where these dry phases, wet phases, information is available for us. This doesn't consider anthropogenic alterations, by the way, so we don't yet consider climate change. That's something that we would consider to be as a consequence of anthropogenic development of resources or activity in different areas, and that would be considered in the next phase. We would look at water use information. What is the demand? What are the requirements for water resources? And using these hydrologic models, we'd be able to propose baseline or provide baseline hydrographs for each analysis site throughout the basin, and we'd be able to present the developed condition for each site across the basin. That would give us some indication of these different user scenarios. For example, we often refer to use and or protection flow scenarios, and those are the scenarios that we would want to query and understand where that suitable balance between use and protection can be achieved, and what would the consequences be of these of each of these developed scenarios for the future. The next step is to look at the ecosystem classification, and here we have a lot of data available for us, available already on the different sub-regions and existing classification tools that are available for different parts of the basin. We have these different ecological zones and regions for the basin already, and we would use that information, take what information is available from the different parts of the catchment and evaluate and determine what are the different types of water resources in the basin. The Sandby Wetlands classification system is based on a series of its own classification steps, levels, and it allows for the classification and identification of different water resource types from the source of the mountain right down to the sea. And in the Nile Basin, it's important because it can allow us to identify what are the characteristics of and what are the types of ecosystems that we're trying to manage. And if we all use the same system, we'll all be talking the same proverbial language when it comes to the environmental flow assessments and the response of different resources to changes in flows. So it's very important that we just use a suitable system. And this system is available for free. You can download it from the Sandby website, which we presented and we demonstrated how to use it in the Nile eFlows framework. What it includes is these different levels from level 1 to level 6. And the first level is to consider inland, the nature of the ecosystem type, Is it an inland system, an estuarine ecosystem, or marine ecosystem? If it's a marine ecosystem, we don't consider it. And in terms of the inland systems, we consider the regional context, ecoregions, sub-basins, or other frameworks and how they've been classified. Any other type of classification where in the region you'd be considering these different types of regional classifications would be listed here. Ramsar wetlands, for example, would be important to identify at that point. Level 3 land evaluations would consider the landscapes, where you'd have benches, plains, slopes, valley floors, and within the landscape, where's this ecosystem? Then we'd consider hydrogeomorphic characteristics, wetland, flat, seep, depression or open water body. Is it valley bottom unchanneled or unchanneled type of ecosystem? Is it a floodplain or a river? What are the characteristics of that ecosystem? Then the hydrological perenniality is considered, flooded or saturated periods are considered, for example, which is very important from an environmental flow context. And then the system characteristics, which is a level 6 characteristic, which would consider the natural or artificial attributes, the salinity and pH, water quality attributes, vegetation cover and characteristics, geology, substrate type characteristics, for example. Those system-specific characteristics that we consider. If this type of framework is implemented and we have the ability to characterize our ecosystems, we can start grouping the different types of ecosystems appropriately and start to apply the framework as it was designed. We also consider the relationship between not only the physical characteristics but the present state of each ecosystem, and this is just this is a simple relationship that's available for consideration, to consider that as an ecosystem moves from its natural pre-developed condition to a completely unsustainable poor ecological state, you have this relationship between ecological health and the amount of use. So prior to any development of use, the system would be considered to be in a natural state, and as you move towards high use, excessive use, then the ecological health would become unsustainable. And you can see here that's what's represented in this green bar at the bottom of sustainability. We'd also try to avoid, we want to maintain sustainability, we want to avoid health, and we want to get the balance between the ecological health and the amount of use right. This refers to, by the way, the health issues associated with human communities. So we're trying to get and manage and keep a system in this good to fair ecological state. We don't want it to exceed beyond a fair ecological state and then it becomes unsustainable. So we're trying to find out where can we propose, and in some parts of the catchment that can be maintained in a good condition, we should work towards that balance between the use and protection of those systems, where we emphasize protection. And in other areas where we know that communities are highly dependent on the resource, we can move towards a fair ecological category, where although there is a relatively larger amount of use, we still ensure that the systems are maintained in a sustainable state. Now we move on to phase 5, the flow alterations phase. And this is where it is important. This is a great example that was also provided from a case study in Kenya. And the example from this case study, to show you, to give you an idea of what the flow alterations for a particular study may look like, is that in the context of the development of this basin, we know what the natural flow regime would have looked like, and we know what was available in the context of water resources prior to the development of a dam. So this was available in the resource. Then they went through a development phase where they created a reservoir, and the reservoir was created to provide hydropower and irrigation. But one of the other benefits of the reservoir was to provide fisheries. So the idea is that we're going to alter this natural flow regime into something that does look very altered, and the release patterns are a lot more stable, you can see, compared to what the flow pattern would look like before the development. But you still have that variability in flows, and you still have a lot of resources and services associated with the resource available for utilization. And the idea is that there are opportunities to benefit socially and ecologically, but maintaining ecosystems, and as a result, the value of that resource overall increases, because we have not only resources available to feed people. We have opportunities for infrastructure and development. We maintain the ecosystem in a healthy, functioning state, and we benefit from hydropower and irrigation opportunities, for example. And what we normally consider these alterations, these development scenarios, in the form of hydrographs. And this is an example of a hydrograph where we've looked at the variability of flows over a year, and you can compare the reference flows with its peak and its wet flow period over future flows. And you can see this is the scenario, the future flow scenario, in terms of the amount of water that's required. And for an example here, you can overlay an environmental flow requirement to show what the environment would need to maintain itself in a sustainable state. And all the flows that exist between this environmental flow requirement over here, represented in the dotted line, and the present flows, is that could be stored water, which would then be available to be released to meet this future demand. But what's important here is that in the system we maintain, and this water would be stored for the future demand in these facilities, but this environmental flow requirement would be provided in the river to maintain that variability of flows and the associated ecosystem that depends on it. Okay, then we move on to flow ecological ecosystem service relationships. And the idea here, and this is an extract from a ProbFlow risk pathway understanding or conceptual model, where what we've considered here is that there are relationships between sources, stresses, habitats, and endpoints that we know that in terms of developments or changes in flows and non-flow variables, for example, associated water quality alterations, we have drivers like climate change, agriculture, dams, communities, infrastructure, mines, livestock and wildlife, and that they all contribute to quantity alterations, quality alterations, habitat modifications, and or disturbance to wildlife. And disturbance to wildlife is considered to be the effect of infrastructure and the activities of human communities and possibly alien invasive species. Then what we try to understand is how, when we've characterized those quantity alterations, those changes in volume, timing, duration, and frequency of flows, how does that then influence these multiple receptors that occur within the in-stream environment, the riparian environment, the floodplain environment, and wetland environment? And with that information, we start to generate response relationships between flows and fish, and flows and invertebrates, and flows and riparian vegetation, and flows and groundwater ecosystems, and the recharge of aquifers, maintaining in-stream pools, and the associated ecosystem and or ecosystem service, for example. And all of that in the context of what we care about. So at this stage, what's really important at this stage of the assessment is to look at these relationships. And here we look at flow and ecosystem service relationships, relationships that are linked to ecosystem types. So what type of features and processes occur within different types of ecosystems, and what would those relationships look like? We want evidence for these analyses. And then finally, we want to establish these response curves that can be used. With this information at this point, only at this point, can we then start to implement an environmental flow assessment. So once we know what the type is, once we've got an understanding of how the flows will be altered, and we've got information on the flow ecosystem service relationship, we can then implement the environmental flow assessment. We can actually at this point determine what are the environmental flow requirements for that particular system. So the environmental flow requirement methods, this is just a quick introduction to the next module. And I wanted to present it in this manner because then you understand what the difference is between a framework and what we're trying to achieve with a framework, and just the method that is used to apply to do the environmental flow assessment at this phase. So once we've got the ecosystem type, measures of alterations, and flow ecosystem relationships, we can start looking at environmental flow assessment methods. There have been 4 categories of methods, and that's generally been accepted. The first is a hydrological category, hydraulic rating category, habitat simulation category, and holistic methods. So although these methods are different, you can see that the hydrological methodology only generally considers hydrological statistics. Hydraulic rating methods then use the hydrological statistics and hydraulic information to provide an indication of habitat availability and different levels and inundation requirements linked to the hydrology. The habitat simulation method then starts to look at different social or ecological endpoints and what habitat characteristics they need, which is linked to the hydraulics of the system, which then can then inform how much water is needed from the hydrology to provide those requirements. But that's only generally independent, isolated indicators. When you start to look at the system as a holistic methods, you consider representing those socio-ecological systems and drivers of those systems and relationships between different variables or components of those systems. And for each of these different methods, they can be undertaken on a reconnaissance, desktop, rapid, or comprehensive level. So I've written it here, that's reconnaissance, desktop, rapid, implementation level where you use the models, or you can look at a comprehensive level of implementation where you look at habitat size assessment, and that's where you generally need the data that's collected from for each of these different types of assessments. So by default, if you're trying to apply the framework, it requires us to consider habitat characteristics and types, which requires an understanding of flow in the environment. So hydraulic rating, habitat simulation, and holistic methods are appropriate. Measures of flow alterations, which is available from different hydrological methods. But then when we start to consider these flow ecosystems and flow ecosystem service relationships, it really does push us to require to implement these holistic methods. So for the implementation of an environmental flow framework and the management of flows on meaningful spatial scales, which in this case is considering the basin scale, we really need to be looking at implementing these habitat simulations and these holistic types of environmental flow methods. Through the implementation of these methods, we then result in environmental flow requirements, and these environmental flow requirements allow us to start looking at the setting of environmental flows and their monitoring. So we look at these requirements, we look at how to monitor whether or not our recommendations for environmental flows are achieving what we've proposed, and in the context of resource quality objectives, we then apply an adaptive management cycle where we start to then look at whether or not the RQOs are being achieved and what the RQOs are, and we're monitoring flows and whether the flows that we propose are being achieved and whether or not that is achieving the RQOs as we've proposed, and that in that adaptive management context. If there are problems with that relationship, we then have to look back at the framework and reapply it or build our information on flow ecosystem service relationships, for example. This is what the outcomes look like in many cases. So these are some hydrographs, and this is an example of different flows that were overlaid. These are average monthly flows that were overlaid from different periods for the lower Nile River. And you can see that what's clear is you have this dry phase and a wet phase. And in terms of the volume of water, you can see that it's relatively high. You have these stable flows that are in excess of hundreds of cubic meters per second, up to thousands. But then the flood periods increase between 6 and over 10,000 cubic meters per second. So that's what we need to understand in terms of the variability. And you can see for these different years there have been changes. In a different types of ecosystems, you can see this is now for the same period, the same monthly period from January to December. You can see in the Nile you have this high flow period between July, August, September, October. But in different parts of the continent, for example in South Africa in the Tugela River, you have these flows that go from almost zero flows right up to 400 cubic meters per second that would represent the high flows. But you can see that it's completely opposite hydrological period when the dry flows and the wet flows occur. So we in Southern Africa generally have a summer rainfall between September and April, and you can see that represented here. And what we would need to understand is to link all of these ecosystem relationship attributes and our understanding of what is required from the ecosystem in relation to these different hydrographs and these differences. And once we understand that and the differences between the two, it would give me the ability to comment on and contribute to the management of flows in a region that has this type of hydrograph or this type of ecosystem compared to this type of hydrograph in this type of ecosystem in South Africa, for example. And that is what the framework is striving to achieve. So the presentation of the results includes annual flows in the rivers. It can be naturally be highly variable. Socio-ecological systems adapt to this variability. That's more of the understanding. We need methods to describe the variability of flows in different ecosystems. We use monthly average flows, daily average flows, which is better. On occasion, we have access to hourly flows, but we're moving away from these monthly average flows because there you can see that even on a daily basis or within a monthly average, there are some peaks that only last a few days. So having access to average daily flows is very useful, and we are actually moving to, on some occasion, these hourly flows, and that's where we have hydropower developments, for example, that are starting to peak at different times of the day, and you get this daily variability of flows, which is important to understand because we need to understand those peaks, for example. So it just shows you the scale of hydrological information that's available and what's used in these type of assessments. Here are examples of monthly average flows from different types of rivers in Africa, and that's what I presented already. The differences between the Nile and the Tugela, for example. Some systems are more seasonal, some are flashy, some are very stable, and we need to understand that and the resilience of the system to changes, because we can start to change and turn these more stable ecosystems into more flashy ecosystems or more seasonal rivers, and what would the implications be? Only the monthly averages are presented, flow duration tables are provided. So this is the format that we've used to present this type of information, but you can see what we've demonstrated here, which is very common, is that we've used the average or median 50th percentile flows for the Tugela River, but there would be daily and monthly variability with these flows. So we would have some indication, especially over a large period of time. So if these were the flows that were integrated and presented here for a historical period which incorporated all of these different flows, we would have to somehow look at the variability of flow between the two. And that's where these flow duration tables are very, very, very useful. So here is an exceedance, a flow duration table where the exceedance values are provided in the context of percentage time exceeded or percentiles. So here we're looking at what percentage of time is flows of 361.5 cubic meters per second exceeded in a particular river like the Tugela River. And you can see that 99.9% of the time there's more than 7.1 cubic meters per second, but only 0.1% of the time there is 361.5 cubic meters per second. So this tells us that these flows are uncommon, and as you move down the percentile list towards 20th percentile, you can see these become more common. So this is an idea of the freshet flows during summer, and then down to the 50th percentiles give us an idea of the base flows during summer and winter, and then the critical low flows. You can see that even though these flows go right down to 5.3 cubic meters per second, that the flows generally don't go down so low, and that if we ever attain these flows that are that value or lower, it would probably represent critical conditions or for that particular catchment. And that is how we would use these flow duration tables, which is becoming quite common in the assessments. We can represent the flow duration tables, as I've shown before. Usually we use these line diagrams that represent, say, the 50th percentiles, the median of the monthly averages. We can use these duration tables that is representative over a longer hydrological period, or any hydrological period. It depends on the period that you're interested in, so that would be important to list and to demonstrate, to include when you're presenting these tables. And we can also represent that information in a Box-and-Whisker plot. And I also like this way of presenting the data because it shows that this is for the same data. Where is the bulk of the flows historically, and this is over a historical period. Where are the peaks, and what is the peaks? What are those peaks? So what are those high freshet flows? You can see here during summer they're between 180 and 250 cubic meters per second. What do the base flows look like? The base flows are here around the 30-40 cubic meters per second, dropping right down to the 10s and 15 cubic meters per second. But it represents all the data and the variability of flows that is experienced by the system. You can see it's a highly variable type of ecosystem. and that would be comparable to what you would find in other areas. So when we present the environmental flow requirements, what's important is to provide information on what the total mean annual runoff would be, and what the cubic meters per second, or what the unit of the outcomes are presented in, because it's million cubic meters or cubic meters per second, for example. Some information on standard deviation and different percentile information. We'd also then provide the environmental flow requirement, which in this case is 544 cubic meters per second in total, and that would represent 46.3% of the mean annual runoff. Then to unpack the low flow, the dry flows, and the high flows, and the different percentiles, you can see that the maintaining low flows requires the bulk of the flows that are provided to achieve this environmental flow requirement. And then in order to implement this environmental flow requirement to different managers, in the context of the framework, what we would generally provide is monthly mean standard deviation data, and then specific information for maintenance years and drought years, for low flows and for high flows. There wouldn't be dry flows during the high flow period, so that's the type of data that would be presented to give guidance on how to then release and achieve the environmental flows that have been determined as an output of these different environmental flow assessments. Okay, so what's important now is to look at roles and responsibilities of stakeholders. So when we're doing these type of assessments, there are multiple stakeholders who are responsible for developments, and there are multiple stakeholders who are responsible for discussing the consequences of altered flows on these different spatial scales. So in this section, we're going to look at some issues pertaining to different stakeholders and their responsibilities that is relevant to the environmental flow framework. So NBI has been identified as and has been commissioned to implement the environmental flow strategy that has been developed for all of the 10 riparian states who occupy the basin. What NBI includes, and their implementation must include, is mainstreaming strategic actions. They must implement work programs and action plans at a national, sub-regional and basin-wide level. And by the way, this all comes from the Sustainable Environmental Flow Strategy. NBI support is provided via NILSEC, NILSAP and NSAP. NBI then also supports mainstreaming of the framework and different intergovernmental partners, different stakeholders, and different regional applications of the framework. They're also responsible for mainstreaming strategic actions, work programs, and action plans at national, sub-regional, and basin-wide levels. NBI support mainstreaming into relevant national and water resource management and sector planning frameworks, policies, activities, for example. That's on a national scale and also a regional scale. Other private stakeholders are encouraged to buy into the approach as well. Then everybody benefits. So for the implementation of the framework, where do we start? So this is our goal. This is what we want to achieve. We want to achieve our understanding of resources, our understanding of variability of those resources to altered flows. We want to understand and determine environmental flows for our resources. We want to be able to relate our need to develop resources with our need to protect resources to achieve sustainability. What is it? Where are we today? What is our endpoint? What do we want to achieve? What do we need to do this? What are the data resources? What are the different plans that we have to achieve this? What do we have today? We have information about flows. We are generating more and more information every day on our understanding of the dynamics of these ecosystems, understanding the biodiversity of the ecosystems, understanding the processes of our ecosystems, understanding the response of ecosystem attributes to alterations in flows, alteration in the volume of flows, alterations in the timing of flows, alterations in the duration of flows, alterations in the frequency of flows. We understand how habitats change. We understand how different biodiversity ecological attributes respond and change. We understand how those different habitats and those features provide services, and how human communities are dependent on those services and how those services change in relation to altered flows. And that information in the framework context can come together to start to understand how to manage environmental flows on meaningful spatial scales. Okay. Yeah, and in terms of this course environmental flow study, it is the first attempt of implementing some of this information to set the environmental flow requirements, even if it's with low confidence based on the availability of hydraulic data, importantly hydraulic information, which is very limited in the basin. But looking at representing habitat availability for different parts of the catchment in the context of flows and associated requirements of those habitats in the ecosystem. In this course assessment, we will propose some of those initial environmental flow requirements, and that will start to provide some of the controls, the limitations for the development, the requirements of the ecosystem to be maintained, to maintain its sustainability in relation to resource development requirements, and that will help us to develop the resources in a sustainable manner. Finally, some literature, some reading recommendations. Again, we'd like you propose that you look at the background documents 1, 2, and 3 from the guidance documents on environmental flow, policy development, strategy development. We'd also recommend that you read the environmental flow framework and technical implementation manual, where all of this has been presented in much greater detail. We recommend that you read the sustainable use of South African inland waters and some of the considerations that have gone into resource development measures 12 years after the development of the National Water Act in South Africa in 1998. And then importantly, to look at water for the environment from policy to science and implementation by Avril Horn and Co. We then recommend that you read the publication on the ELOA, Ecological Limits of Hydrologic Alteration, and finally visit the ELOA and environmental flow websites that are available to explain how some of these frameworks have been implemented in case studies around the world. I'd like to thank you again for your time, and I hope that you've benefited from this, this blended learning module, and please would encourage you to look at the final set of 3 modules that precede this blended learning module number 2. And if you have any questions, please to contact info@Hydroc, the Nile Basin initiatives themselves, and also to look at our website at the University of Mpumalanga. Thank you very much and good day.